Hello, we're going to be talking about properties of inequality. All right, so let's look at an example. X minus 8 is less than negative 11. We're going to add 8 to both sides to get that x alone using our addition property of inequality. We're going to get x minus 0 is less than negative 3, which simplifies to x is less than negative 3. So that's our possible solution. Now we need to verify it. And because we have an inequality, we are going to check 3 different values. A value that should be in the solution set, a value that should not be in the solution set, so we'll get a false answer, and we're going to check the result. So we're going to try a number less than negative 3, a number greater than negative 3, and we're going to check negative 3. So let's start with a number smaller than negative 3. So let's use negative 5. We should get a true statement, right? Because negative 5 is less than negative 3. So when we put that into our equation, we get negative 13 is less than negative 11, which is true. So that's good stuff. Now we're going to try a number bigger than our result. So 0 is bigger than negative 3, right? So we should get a false number because 0 being larger than negative 3 is not less than negative 3. So x minus, excuse me, we put 0 in for x, and we get negative 8 is less than negative 11, which is false, which is what we expected. So that's good. And now we're going to use our result, negative 3. And we should also get a false statement because negative 3 is not less than negative 3. They are equal. So when I put negative 3 in, I get negative 11 is less than negative 11, which is false because they're equal. So I have shown that values that are less than negative 3 make that statement true, and negative 3 and anything larger make it false. So now I am going to graph. So what I'm going to do is I am going to look at my inequality. X is less than negative 3, and I'm going to find the negative 3, and I'm going to put an open circle. And all of my solutions are less than negative 3, so that's to the left. So I am going to draw my arrow, and I'm going to make it chunky enough so that it's distinguishable from the number line. So this is my solution set. Everything less than negative 3. Let's look at a different one. Solve negative 8 is greater than 2 minus 4 minus x. Okay, well this one's a little more complex, but it's exactly like solving an equation, which we know how to do. So when we look at this one, we have to remember that this is an invisible negative 1, right? And we're going to distribute negative 1 to each of these. So our first step is to do that. We're going to distribute negative 1 to both the 4 and the negative x. So I have 2 minus 4 plus x. And then I can combine my 2 and my 4, right? Because they're like terms. So I get negative 8 is greater than negative 2 plus x. I want that x alone, so I am going to add 2 to both sides. And I get negative 6 is greater than x. And I can reverse that, right, to put the variable on the left. It becomes x is less than negative 6. Now remember, if you reverse the order of your inequality, you have to change your inequality symbol. See how the small part points to the x here, and it's still pointing to the x here? That's what you need. So our possible solution is x is less than negative 6. So we're going to try 3 values, right? We're going to try a number smaller, a number bigger, and that number. So a number smaller than negative 6, let's try negative 10. We should get a true statement because negative 10 is less than negative 6. So we put negative 10 in, and we simplify, and we get negative 8 is greater than negative 12, which is true. So good. We've just shown that numbers in that are less than negative 6 make this true. Now we need to try a bigger number. So we're going to try 0 because 0 is greater than negative 6. So we put 0 in and we should get a false statement. And when we simplify, we get negative 8 is greater than negative 2, which is false, which is what we want. So we now have proven that anything less than 6 is in our solution set. Everything greater than negative 6 is not in our solution set. And now we need to look at negative 6 itself. So when I use negative 6 is not less than negative 6. So I should get a false statement. So when I put negative 6 in and I simplify, I get negative 8 is greater than negative 8, which is false because they're equal. So then I'm going to graph my solution. I'm going to say x is less than negative 6, so I'm going to find negative 6, and I'm going to put an open circle there, and then I'm going to draw my arrow to the left because my solution set is less than. All right, let's try negative 4 is less than negative 2x. How do I get my x alone? I need to get rid of the coefficient there, so I'm going to divide both sides by negative 2. But when I do that, because I'm dividing both sides by a negative, I have to remember to flip my inequality. So I always circle the inequality when I'm multiplying or dividing by a negative number, so I remember to flip it. It's like a visual cue. So negative 2 divided by negative 2 is 1. Negative 4 divided by negative 2 is 2. And I flipped my inequality. So I get 2 is greater than x, which I can write as x is greater than 2, which I didn't need to write because I typed already. Okay, so now we need to verify. This is our possible solution. X is less than 2. So we need to check 3 values. One that's smaller than 2, one that's larger than 2, and 2. The one that's larger and the one and 2 should both be false. So let's substitute in a number smaller than 2. We should get a true statement. So let's use 0. Negative 4 is less than negative 2 times 0, which is negative 4 is less than 0. That's true. So yay us. Now we're going to use a number larger than the result. So we'll try 3. We should get a false statement. Negative 4 is less than negative 6. Well, that's false. So good. Now we need to use our result 2. And when we put that in, we should get a false statement. So we get negative 4 is greater than negative 4. Why is it greater than? It should be less than. All right. Oh, teacher error. This should be negative 4 is less than negative 4. I have my inequality backwards. So we have verified our solution. So we put an open circle on not the positive 4, and there is no negative 4 here. Right, because I'm losing it. Okay, teacher insanity. Our solution is x is less than 2. So open circle on 2, arrow to the left. All right, well, here is an example of an inequality that will have no solution. So we have 4x minus 4 is greater than 7 plus 4x. Well, we have x's on both sides, so let's fix that. So we're going to subtract 4x from both sides, and we end up with negative 4 is greater than 7, which is false. So when we solve an inequality, excuse me, and we end up with a statement that has no variables and is false, just like with equations, this means there is no solution, which for inequalities is expressed as the empty set, which is a 0 with a slash through it. It's not really a 0, it's more of a circle with a slash through it, but whatever. And how do you graph no solution? By not having a graph. You just have an empty graph. All right, and like equations, we can have an example when we have infinite solutions. So if we have negative 2 times the quantity 2x plus 1 plus 5x is less than x plus 5, we distribute the negative 2, and then we combine the negative 4x and the 5x, and we get x minus 2 is less than x plus 5. We have x's on both sides, so we're going to subtract x from both sides. And we end up with negative 2 is less than 5, which is true. Which means that just like equations, there's infinite solutions. Every real number makes this true. And the way we graph that is by just graphing the whole thing. Our line has arrows on both ends, and that is the solution.